At this point, we're going to go through the steps to kind of assemble the Pi-Swerl and get it ready for a test. It's fairly straightforward. Essentially, what we want to do is we want to put the dust track inside of the cradle, which holds it. We want to install a battery into the control box. We want to connect the control box to the Pi-Swerl, and then we want to also install the cradle on the Pi-Swerl, and then we'll be ready to do the testing. So let's go through those steps one by one. We'll start with putting the dust track in the cradle. The cradle is basically going to hold the dust track, and then these two thumb screws on the top black bar. And you can just unscrew them. And the top black bar comes out easily. Make sure you save those screws. And the dust track actually gets installed upside down, like so. So that the inlet is at the bottom. And then you carefully reattach the black bar. And then that should hold the dust track firmly in place. This should be a little bit snug, but not too tight. Sometimes it's a little bit tricky to get that screw in. Just be patient. There we go. Okay, so we'll show how this works later, but this is essentially the power cord for the dust track, and that should just remain there for now. Okay, next we'll talk about how to install the battery into the control box. The control box cover is held in place with these thumb screws. There are 4 of them, 1, 2, and then there are 2 in the back. And I'm just going to unscrew them. And put them on the side. And when I do that, then I'm able to remove the cover and reveal the inside of the control box. In order to install the battery, grab the battery by the sides. There are these slotted areas where your fingers can go in. And then with a dongle facing the back end, you insert the battery. It sits nicely in there. And then these plugs are used throughout the Pi-Swerl, but these are twist lock plugs, and they're keyed. And then there's a very wide key that is sitting at the top of this plug over here, and that's what you can use to approximately position where the plug will go. The way these work is you try to align the keys, and as the wide key is towards the top, and you just rotate them lightly until they feel them click in place. And the final component is to actually twist the lock in place. And you'll feel a slight click. Let me do that again. There's the key. There's the wide part of the key. This component twists in place, and that's what locks it. And what you'll do is you'll align the wide component of the key with the wide component of the lock, and you'll feel it go in when that happens. And then you take the circular part and you lock it in place. Now this battery is loaded in. So I will replace the cover. Now replace the thumb screws. Okay, a few more steps. This is the keyboard. I'm going to move it to the side. I'm going to remove the cover of the control laptop. There's a little band that's holding it in place. That just comes off. And then there is a cable that connects the computer to the Pi-Swerl control box, and this allows the two to communicate. It's the same thing. There's a key. There's the wide component over there. That's aligned with the top. You feel it click into place, and then you just rotate this to secure the connection. The keyboard is wireless but USB operated. So if you want to maintain power throughout, you can plug it into the USB port at the bottom, or if it's already charged, you don't need to do that. It will operate wirelessly. Okay, so that's ready to go. Next, you'll want to mount the dust track cradle and the Pi-Swerl handle onto the Pi-Swerl, and that's easiest to demonstrate on the floor. Basically, the cradle just sits on top of this platform over here. The inlet of the dust track points towards the area where there's an exhaust, a small exhaust nipple coming out of the Pi-Swerl. It's the black line over here. And you're going to use these 4 provided thumb screws to secure the cradle in place. This serves to attach dust track to the Pi-Swerl, but it also serves as a handle. Next, you're going to make the connections to the dust track. There are 3 connections. The first is the pneumatic connection. So you have to connect the inlet hose to the inlet of the dust track. And that's just a slide. Next is the power connection. The power connector clicks into place there. And on the actual Pi-Swerl body, there is a clicking connector which can only go in one way, and that just gets pushed into place. You can hear it click. The third thing that you have to connect is the communications cable, which is this green cable, and that connects simply into the Ethernet style port that you see over there. Finally, in order to connect the Pi-Swerl to the control cable, you use, again, the same twist lock type cables on the Pi-Swerl. Twist lock is located over here by the blower. It doesn't matter which side of the cable you use. They're through cables, so it's the same. The widest notch goes in the top, rotates and clicks into place, and this other one goes on the port on the control box that says to Pi-Swerl. Which is located right there. And that's it for the assembly of the Pi-Swerl. At this point, you're ready to turn on the instrument and start doing some testing. Once all the connections are made, you're ready to power up. So you press the power button over here. It lights up. And what happens immediately, if everything's connected properly, is that you'll notice the dust track comes on by itself. The screen comes on. It's upside down, of course, so that's not going to rectify. That's going to remain upside down. But that's how you know that it's getting power. And sometimes the computer turns on by itself. If not, you have to actually manually turn it on. There's a switch down here. But oftentimes it'll just turn on by itself when the power comes on. Once the computer is turned on, then it does use a Windows 7 operating system. You'll see this dialog box come up and it says, please wait for Pi-Swerl hardware to initiate. Basically, this is the operating system making sure it can communicate with all of the different devices, and you just have to wait for the clock to run out. And once it does, you get a little command box that says Pi-Swerl hardware is ready to run, in which case you press OK. This is a touch screen control panel. And what you're going to do in order to initiate this worldview program is to double click on that center icon. All of this, of course, can also be done with the wireless keyboard, which has a mouse pad and mouse click buttons there and there. The first screen you'll see is the test specification panel, and we'll go through how all of this works. So this is the main Pi-Swerl chamber. This is basically what does the measurement for you. There are a couple of different components. The main chamber is this cylindrical part. Then here you have a clean air blower. So air is sucked in through here and then routed through to this flow meter and then directed inside the chamber. And then that air, in order for the mass balance, is forced out of here. So dusty air will come out of here. This is the dust track, obviously. It's sampling the air inside the chamber through this tube. You can see the main motor that operates the Pi-Swerl blade is there. And then that motor is connected by a shaft to this blade, the main annular blade of the Pi-Swerl. And this is what spins around. And this is what we refer to when we're talking about the Pi-Swerl RPM. It refers to the rate of rotation of this blade. Also in here you see the optical gate sensors. There's 1, there's 2, and 3 and 4 at the higher level. So these are the OGS optical gate sensors, sometimes also called optical gate devices or OGD. So during a typical Pi-Swerl cycle, the blower will come on for some period of time and just vent out the chamber with a little bit of clean air in case some dust got lofted during the time that you place the Pi-Swerl. And then after that period of time, then the motor will be told through the program, which we'll go through, at what speed to start to rotate and how long to maintain that rotation. And at the end of the cycle, then what will happen is that typically you also send clean air through the chamber to flush out any remaining dust that occurred during the course of the test. All the while, data are being collected by the dust track, from the flow meter, from the RPM sensors, and all of those, and also the optical gate devices, and all of those are being stored onto the control computer. So this is the main Swirl View screen. You notice several features over here. The first thing you notice is that there's a Programs drop-down menu, and this is essentially where the different pre-programmed cycles are stored. And when you click on that arrow that has a list of these different programs, these have just been custom named. H4000, for example, stands for Hybrid Test 4000. R4000 stands for Ramp 4000, but you have the option of naming them whatever you like. You also have the option of modifying any one of these programs. Here's your Modify button, and we'll go through that in a second. But beneath that, you have a text version of what the program does. And in the left-hand column, you have the number of seconds, and in the right-hand column, you have the RPM setting. So for example, the first entry tells you that you're going to have 0 RPM for 60 seconds. And what that does is that turns on the blower on the Pi-Swerl and starts introducing clean air into the chamber, but the RPM for the main annular blade will be 0. In other words, it won't be spinning. So you'll just be introducing clean air. And you have a graphical representation of that over here. So for the first 60 seconds, the RPM is 0, and you're just introducing clean air. The next entry in this table is 60 seconds, 2000. And what that means is basically take 60 seconds to go from the current RPM, which is 0, to the target RPM, which is 2000. In other words, it's going to ramp from 0 to 2000 RPM linearly over a period of 60 seconds. Again, that's shown graphically here. The RPMs are 0, and then over a period of 60 seconds, they're elevated to 2000. The next instruction is, again, 60, 2000. Since you're already at 2000, then you won't be actually changing RPMs, but this instruction will be interpreted as hold 2000 RPM for 60 seconds. And you can see the rest of the cycle is also interpreted there. And then the final entry, again, 60 seconds, 0. What that'll do is that'll cut off power to the motor, so you have 0 RPM target, and for 60 seconds it'll flush out the chamber. So that's the text representation of the program cycle, which is shown here graphically. The other button you see is the next button, which means that once you've selected the program you want, you're going to press the next button for the next thing. And then finally there's an exit program, which if you are done doing your Pi-Swerl testing for the day, you would want to press. Over here there's an indicator for any one of the tests, which shows you the duration of the test in seconds. So we know, for example, this H4000 test is going to last for 540 seconds the way it's programmed now. By the way, when the monitor screen falls asleep, then the best place to tap it is in the top right corner, so as not to interfere with any of the buttons, and then that'll wake the monitor up. That's as a power saving feature. If any programs want to be modified, or you want to make a new program, you press that Modify button, and then the screen comes up. We won't go through how to operate it, but it's fairly straightforward once you read the user guide. Okay, at this point, we're ready to start a test. We've selected our H4000 as the test that the cycle that we're going to run, and we press Next. The next panel that pops up after you hit the next button is this test description panel, and this is an opportunity for the user to enter in some information into these orange text boxes. And you can enter into one or both or neither, but two are offered. And again, using the keyboard, you can put in, for example, some description of what it is that's going on. And then perhaps you could say something about the surface that you're testing. So in this case, of course, this is just a test surface, so it's a table. And once we're satisfied with this, we can hit run. One thing I wanted to note is this unique test ID number up here. And basically, this is a unique number that's associated with each test. And this is a way of referencing individual entries in the data files with the metadata for that test. So this is a way, essentially, of uniquely identifying every single test so that you know when it happened. It's usually not a bad idea to write down this unique test ID along with some other descriptions of the tests that are relevant. And once that's done, and you're happy with that, then you can hit Run button. The first thing you'll hear when you hit Run is you'll hear the dust track initialize and come on, and you'll see that it'll start sampling on the front. Next thing you'll hear is the blower coming on and trying to achieve the target flow rate, which is 100 liters a minute. And you can see it's creeping up towards 100 liters a minute. The concentration of the dust track, because it hasn't been calibrated, is negative 0.015, but that's what it shows in real time. And then this green light tells you that there is communication ongoing between the control box and the dust track. The target RPM is 0, because recall we're going to be flushing the cylinder with clean air for 60 seconds, and then the actual RPM is, of course, also 0. After 60 seconds have passed, which will be in about 10 seconds or so, you'll hear the Pi-Swerl motor come on, and you'll start seeing the RPMs increase, trying to achieve the target values set by the program. This is the main viewing panel. There are actually different tabs here. You see this one is called Main View. And what this plots is essentially plots the progress of the test. There's a red trace, which is the actual RPM. There is a white trace, which is the target RPM. Oh, I have those switched, excuse me. The red trace is the target RPM, and the white trace is the actual RPM that the Pi-Swerl has achieved. The green trace is the concentration as measured by the dust track, and that's on this scale. Of course, we're on a clean surface, so the concentration is very near 0. And then the yellow trace, if it appears, is the OGS peak. So that's a sort of an aggregate value that tells you whether or not there's a lot of sand movement going on. On the main test panel, there's a stop button. In case the test needs to be stopped, you would press that, and that would cut the power to the motor. And then we already explained what these different indicators are. There's also a stop dust track button, which allows you to stop only the dust track, but the rest of the test to go on. There's a right OGS indicator. I think for most of the applications that should remain on no. Do not turn that on unless you specifically want to write the OGS data in very high, at a very high rate of speed, which ends up being an awful lot of data. So unless you know what to do with it, it doesn't make an awful lot of sense to do it. There's the battery voltage indicator there. You can see the battery voltage is about 26.2 on this fresh battery. And then there's also a latitude and longitude number. We can switch to OGS history, which shows the kind of the history over longer periods of what the OGS sensors have seen, and then OGS real time, which show in very high time resolution what the OGS sensors are seeing. And if this was a sandy surface, you'd see a lot of dips associated with a blockage of light through the OGS. But most of the time, you'll be observing the main view program. Okay, at this point, most of the test is complete. You can see that we've gone through the cycle, and right now the blade has come to a stop and the chamber is still venting. The test is still ongoing, as indicated by this blinking light. There are only 5 seconds left, and at the end of that 5 seconds, there we go. Okay. So a little dialog box came up, and it's giving me the option of entering in the latitude and longitude for this test location manually. And the reason it's doing that is because the GPS that is on the Pi-Swerl, because we are indoors at the moment, was not able to get a lock. So it's not able to obviously write down the coordinates into the metadata file. So this gives you the option of actually putting the coordinates into the metadata file if you'd like. I'm going to skip that option. And the next dialog box that comes up, it says, would you like a new test or do you want to exit? And if you press exit now, then the software quits and you're done. If you want to run another test, on the other hand, you press new test and you're basically back to this screen. Good. So let's say we're done for the day with our testing. I'm going to hit the exit program, and that closes the program. I also wanted to show you where the data are stored. There's a Swirler data shortcut over here. And what happens is every time that you run the Pi-Swerl, it will create a new folder with the date that the tests were done on. In this case, this was done on September 19th, 2017. And this is where our test data files are written. There are files that start with the word data, and they have a bunch of numbers after them, and those are the files where the data are stored. And there's one file in that directory with the word that starts with the word info, and that's where all the metadata are stored. And I'm just going to open that up really quickly to show you. The first field in the info file is the test ID field, which we talked about, and then this uniquely ties the information in this file with the information in the data file. And I'm just going to close those up.